Okay, we are going to go over our activity for 3.3. Hopefully, it would be best if you could print this out. Otherwise, a lot of this is on the first page right here is what we went over in the notes video for this section, 3.3. How we create our confidence intervals. We take our statistic plus and minus the margin of error. The margin of error is the multiplier times the standard deviation of the statistic, meaning the sampling distribution. Okay, so we're going to estimate the confidence interval using 95% confidence interval. T is the multiplier for other confidence levels. And this is our review here of the central limit theorem. Again, we went over this in the previous video for the basic notes for 3.3. So what we're going to do in this activity, again, hopefully you can print this, otherwise you can just kind of jot it down as we go along. We're going to revisit our sleepless nights. Recall when we did the survey in class about how many hours of sleep you got the previous night? And I input that data into StatCrunch. And that's the data we're going to use today for this, okay? So the parameter of interest for this study, recall, was the average hours of sleep an ARC student got the previous night. Average hours of sleep average hours of sleep an ARC student got the previous night. Mu is the symbol because this is a parameter. The population is ARC students. And the parameter is the average hours of sleep an ARC student got. So that is mu. Going back to StatCrunch, you can pull up your data. Let me see if I can quickly show you that in my computer. So I'm just in StatCrunch. I'm going to click on our group, and the sleep survey for me, I don't know if it's because I just have a really big font, is on the second page. So I clicked on that. There's our data, all right? And if you recall, we go to Stat, Summary Stats, in the columns, and I bring my data over, and I want, well, let me just get the sample size. I'm going to hit Control as I click so that I can just take the three values that I want. The sample size, the sample mean, and the sample standard deviation, and there it is. So I'm going to jot this down. I'm going to round to 2 decimal places, all right? So let's just go back here, and that's what I have. My sample size is 24, my sample mean 6.35, and my sample standard deviation 1.84. So now, this next part, I'm just kind of going to walk through quickly because I want to get to where we're actually going to create the confidence interval. All right, so in C, it's simply saying what would be a good guess for the estimate of mu. We could use our actual sample mean, 6.35. Was it a simple random sample? Remember, it was not. It was a convenience sample. So if I said 6.5 would be my estimate based on my sample, what I could do is just perform a test of significance. And doing that, if we did go to the one mean applet, we'd find a p-value of 0.514 because we are testing it against our sample of 6.35. And 6.5 is not far from 6.34. Or actually, it was 6.35. So 6.5 would be a plausible value for mu. So remember, we're not going to do this now, though. We're going to go straight to our confidence interval. We're going to calculate a 95% confidence interval using the 2 standard deviation method. So our multiplier will simply be 2 to give us the approximate 95% confidence interval. This is just a reminder of the central limit theorem. Does our sample meet the conditions needed to use the central limit theorem? Yes, it does, because our sample size is 24 and the sample size has to be greater than or equal to 20. So we're good for the conditions. We can assume that the sampling distribution of all these sample means would have a normal or bell-shaped. So now to calculate the standard deviation, all right, we've got our sample mean. We're going to use 2 as our multiplier. We need the sampling standard deviation. So we only have the sample standard deviation. We do not know the population standard deviation, so we're actually going to use the standard error. So we take our standard deviation from our sample, 1.84, which we just calculated, divided by the square root of the sample size. We get 0.376. This is the standard error of the sampling distribution. Not necessarily the standard deviation, but the standard error approximates the standard deviation. So this was the standard error, which is good to use also. All right, so again, that's that piece of the puzzle that we just computed, the standard deviation of the sampling distribution. We calculated the standard error. So this right here is that piece, the standard deviation. This whole piece, 2 times the standard deviation, remember that's our margin of error. That's the amount we go up and down from our sample statistic. So, page 3. So now we're going to actually calculate our margin of error. So we have 2 times the standard deviation of our sampling distribution, 0.752. That's our margin of error. That's what we add and subtract from our sample mean of 6.35. So when I subtract, I get the lower end of my interval. When I add, I get the upper end of my interval. So again, I'm taking 2 for approximating the 95% confidence interval, 2 standard deviations of the sampling distribution, which we used the standard error because we don't know the standard deviation of the population. That's my margin of error. That is the amount I add and subtract from my sample mean, creating my interval. How do we interpret this interval? We are 95% confident that the average amount of sleep an ARC student got the previous night is between 5.598 hours and 7.102 hours. There's my units, hours. Okay, we need to have the units on there when we're talking about means because they change from problem to problem. So again, 2 is just the approximate 95% confidence interval. So the Z multiplier that we use for proportions stays the same no matter what the sample size is, but for means, we have to find the t-score multiplier based on our sample size. So what are our degrees of freedom in this problem? Our sample is 24. So we have 23 degrees of freedom. So this is where we would need to go to the table that is on the back of the very last page of your activity is this table that I showed you before. So I would need to zoom out a little bit so I can get a bigger picture. So I'm going to go to 23 degrees of freedom. There we are at the bottom there, 23 degrees of freedom. And 95% confidence interval. Come down where I have 23, and there it is. 2.069. 23 degrees of freedom, because we have a sample size 24. 95% confidence interval. That is going to be the T multiplier that I will use for this interval. 2.069. So to create the interval, this is just a more precise, exact 95% confidence interval. Remember, using 2 was just an approximate. Now to be more precise, I use 2.069 according to my sample size and the confidence level. Still multiplying it by 0.376 because that hasn't changed. That's still my standard error, standard deviation of the sampling distribution. The only thing that's changed is my multiplier. So I take my sample, 6.35, I add and subtract my new margin of error, 0.778. Here is my more precise interval. Compare it to my interval I created with the 2 standard deviation approximate method. You can see they're very, very close. This one is slightly wider, slightly, because I'm just being a little bit more precise and I had to go a little bit farther out to get exactly 95%. If I wanted to find a 99% confidence interval for 99% confidence level, again, degrees of freedom 23, but now I'm going to move over to the column. There's my degrees of freedom 23. I'm going to move over to 99%. There's the column for 99%. I'm going to use a multiplier of 2.808 for 99%. 2.808 is now my multiplier. So here's my sample, mean. I'm going to add and subtract. My multiplier has now changed to 2.808 times my standard deviation. So remember that this piece right here, 2.808, the multiplier times the standard deviation of the sampling distribution, that product is your margin of error. You add and subtract that to your sample mean, and this will be your interval for 99% confidence. This is how we interpret it. We are 99% confident that the average amount of sleep an ARC student got the previous night is between 5.29 hours and 7.41 hours. Now I'm going to bring us to the applet and see how the applet will create this for us. All right. Got to bring my computer back up. Okay, bring it forward a bit and put that right there. Okay, my little contraption here is a little wobbly. Okay, I'm going to go to my applet, which I have up right here. Nope, here. Here, haha, got it. Okay, so I'm going to the theory-based inference. Is that focused? Theory-based inference, right here. And now remember, the scenario needs to be on one mean now. We're not working with proportions, we're working with means. Now you can paste your data in here, right in the box from StatCrunch, or we can put our summary statistics in here if I already have them. So N would be 24, my sample mean 6.35, and my sample standard deviation was 1.84. And just calculate, and there's my info. Now, let me just show you how, if we need to take data from somewhere, okay? Are you including the header or are you not including the header? I'm gonna not include the header right now. So I'm gonna go to my StatCrunch and I'm gonna close this box. I'm gonna come here, right? I'm gonna click on the first box. I'm gonna scroll down to capture all my data. And then remember, it's Control C to copy. I'm gonna come back over here to my applet, and I'm in the box, and I'm going to Control V to paste. And making sure, you're gonna get errors if you haven't changed your scenario to be means instead of proportions. I'm gonna use this data, checking my summary stats here to make sure I got everything. 24, mean is 6.354, standard deviation 1.844. So everything's good. Theory-based inference over here. This is where we did our test of significance for the p-value. We're not doing that right now. I just want to find confidence intervals. So there's 95%. If I calculate that, that should be pretty close to what we got for our 95% confidence interval. Let me bring it up here and show you. So here was the precise one. Theoretically, when we used the multiplier of 2.069 right here, we got 5.572 to 7.128, 5.5753 to 7.132. So it's very close. That would be just some rounding differences. All right, so if I want the 99% confidence interval, calculate that, and notice that's what we got pretty much when we did it by hand using our table. 5.2973, we got 5.294. 7.4107, and we got 7.406. Again, this is just rounding differences right there. So for the applet, all we have to do is get our data in the box over here. We go to the theory-based inference. Make sure you're in the right scenario, means or proportions. You can either paste your data right in here, or you can input the sample statistics, tell it what confidence level you want, and voila, it gives you your interval. If we are looking for a 90% confidence level, we can use the applet, like I just showed you, or you can use your table. You would have to change your multiplier. So in your table, 23 degrees of freedom, let's see, 90% is the next column over, so 1.714 would be your multiplier for 90%. Otherwise, again, you can just use your applet, and this is what you're going to get. When we interpret, we are 90% confident that the average amount of sleep an ARC student got the previous night is between 5.709 hours and 6.99 hours. And then we just have a little summary of what we've gone over. Now remember, when you have a confidence interval, the midpoint of that interval is always your sample mean, because the sample mean is how you are creating your confidence interval. So that's really important. If you're given some confidence interval, you can say, oh, I can find the sample mean because it's right smack dab in the middle. How would I find the middle? Let's just take, for example, the 5.71, the one up here. This confidence interval right here. I'm going to round it. 5.717. Okay? If I find the exact middle of that, it's just finding the average. That's finding the middle. So if I go get my trusty little calculator here, and I take 7 plus 5.71, divide that by 2, 6.35. That is our sample mean. So if you know the interval, you can find your sample mean by just finding the middle of the interval. Okay? You can also find the margin of error. The margin of error is half of the width of this interval. So if I found the difference and divided it by 2, right? The difference divided by 2, that's going to give me the margin of error. This one, when I find the average of the two, gives me my sample size. So let's once again get the trusty little calculator here, find the difference this time. 7 minus 5.71. And then I divide that by 2. Take half of that width, 6.45. I mean, 0.645, sorry. That is the margin of error. That's your margin of error. Not me, but the margin of error. All right? So that's some important little things to remember there, okay? That you can always find your sample mean by finding the midpoint of the interval, like we did right here, and that the margin of error is half the width of the interval, like we did right here. Okay. See you next time.